So we actually have like a workshop we tell our customers about, and that they can actually experience the power of generative AI. And the idea is that, of course, you can query your structured as well as your unstructured data. So obviously, we want to help our customers accelerate decision making, gain insights, business insights very fast. We also want democratization of data, right? So those are the advantages. The capabilities that enable all of this is, of course, natural language to SQL. So given a table, we can help you figure out insights with natural language questions, right? We can also load unstructured data into MySQL HeatWave, and you can ask queries of that unstructured data and get inputs. So this is a typical example of where someone asks a question about some structured table data, right? The product with the best year-on-year growth in terms of total amount sold is the watch. So that's what the response was. So what are our top selling products by revenue in the last quarter? So it generates an SQL, it runs that SQL and gives a natural language response, as you can see here. You're getting a natural language response to your query, right? And you can keep asking, you can dive deeper into the same query and ask more and more complex questions, right? In 2025, actually, McKinsey actually performed a survey, and they realized that a lot of organizations are piloting generative AI, and there's very high curiosity for AI agents. There are positive leading indicators, and there's bound to be growth, right? And we need to be able to leverage those capabilities. So what common challenges are faced by someone who wants to run generative AI applications, right? One is, of course, a complex infrastructure. You would have set up for agents, you'd have a setup for vector databases. You'd have to, create context, really large context for your large language models. You'd have to deploy those large language models. So all of that has to be integrated, and it becomes very, very complicated. Then, of course, different platforms, and there's the ETL for the data, and then there's storage of the data, and then there's the staging of the data. Generative AI, the way it is, tends to have hallucinations. And of course, even bigger is the fact that, security and privacy, right? You ideally don't want your data going outside. So if you have a third-party model completely outside of your network, challenges that you're actually exposing your data, right? When it comes to unstructured data and structured data, processing those need speed, because there's a lot of insight stored in there. And of course, high cost, right? Especially with large language models that are external and licensed vector DB products. That makes it extremely costly. With the MySQL AI platform, all of this becomes very simple, right? You have MySQL at the center. It has capabilities such as the vector store. So the customer doesn't have to run a separate setup for vector store, like a Milvus or a Pinecone or something like that. Then you have the embedded LLM, which is right inside. Okay, so you don't have queries going outside. You could essentially run all of your natural language queries inside the database itself. Having said that, of course, there is capability to integrate with external generative AI hosted models. Then, of course, there's NL to SQL, there's support for MCP servers, and of course, AutoML that works together with generative AI to give you those kinds of capabilities. So I'm actually going to kind of run through this a little faster. So essentially, what do we have, right? We have a single platform. We have pretty much everything self-contained. You can build an end-to-end generative AI pipeline, right? There's no fine-tuning or anything at this point, but mostly there are very few people who actually do fine-tuning. So mostly all of this can, whether it is grounding through RAG or NL to SQL, all of that can be built within the database itself, right? Without transporting your data, using external models, and easy migration, right, to the cloud, essentially. So the idea is, of course, you will be able to build your applications, whether it is structured data, whether it's unstructured data, or you use AI agents. All of this is possible within the database itself. So this is the set of shall we say, procedures for generative AI and machine learning. You've kind of seen the machine learning part. I'm just going to talk to you about generative AI. Of course, there's ML Generate, which enables you to generate responses in natural language. Okay, this can be used for summarizations. This can be used for translations. You can create vector store tables, tables with vector columns. You can run ML RAG on an entire table where you kind of point ML RAG to the vector store, and you can use that vector store to enrich the context that goes to your LLM. And of course, you can create embeddings. You can create embeddings across the table. You can do NL to SQL. Right, and you can retrieve, if you want to go even low level, you can retrieve schema metadata within this. So this is, of course, the MySQL Studio, and what we're going to do is we're going to try to see if we can do some natural language processing, right? So first we create a sample, select a sample table, and then run. So this is a natural language query. How many airlines are there? Okay, so this is a query we are asking of the airport DB or airline, and we specify the airport DB schema, and we say, so what we're generating is a SQL based on our natural language query. So you can see the SQL, right? Now, I'm going to run the SQL, and once you run it, you get a response, 113, right? So this is basically running with a query. Now here's what we're going to do. We're going to load a document into the vector store. So this is, again, a document that's in your OCI object storage. And we can specify a name for the vector store table. We say that the airport schema is what we're going to use. And we've actually kind of done that previously. So this kind of gives you a sense of the ability to query data. Let's put it further. So we want to. So this is a very straightforward query. Summarize the key features of MySQL high availability. So we loaded a document relating to MySQL HeatWave, and let me move this forward a little bit so that we can see the output. And there you have it, right? So you have certain reference architectures, integrated tools, disaster recovery, so on and so forth. So we actually loaded a data that was. So here's another example of NL to SQL. So earlier, what we did was we loaded unstructured data. It's a piece of documentation, and we ran vector store queries on it using natural language. In this case, we have structured data, and we are going to run natural language queries that would be translated into SQLs, and then those SQLs will be executed. So this is something that we created for a logistics company. So how many trucks started their journey in the month of October, and we get a generated SQL, and then we get a raw answer that is the output of the SQL, and then we can translate that into natural language responses. Which day of the week do the highest number of trucks start their journey? And so we get the generated SQL, and then we say, okay, we want the raw answer. So the raw answer is 1, and the data indicates the highest number, so on and so on. Okay. So so one is, of course, the day is Sunday, and that's why it says one. So there are many other such capabilities. Let me stop this here. Okay, so you see how many trucks started their journey in the time period of October 25th to 30th, year 2025, and I don't know, something else, I guess, and are on time. So how many have been delayed and so forth. So we run this query, and we get a generated SQL. And once we've generated the SQL, we run the SQL, we get a response of 233. And then if you want, you can take it back to the LLM and generate a conversational response, right? Again, similar thing, but with a different set of data, this time movies, actually, and we're using an external model here, not the internal model, just to show a capability for integration, right? So we're going to browse the data set, and we're going to load this data and provide probably some minor explanation. And let's move on while the data gets loaded. Okay. Okay, so there is a preview of the data here. Okay, so we see customer name, customer email, so on and so forth, product name, product category, all of that. Okay, and so this is a sample of the table. Now we have a question, and give me the top 10, I don't know, a list of top 10 customers, right? So it's a fairly open-ended question, probably going by revenue at this point, but we'll see. So occasionally you might see a kind of slowness. That is because the model's getting loaded or there's some initialization going on, but subsequent queries will be much faster. But here it is, right? So you got a query in response to your question. You can see this descending limit 10, and you got a list 6. So yeah. So here number 6 is 1, 2, 3, 4, right? So that is one, give you a better idea. So here's the things, right? Which are the products that sold most. So I'm moving on. Yeah, so retrieval aggregated generation or augmented generation. The whole idea is that HeatWave has a vector store, and there's a large language model. The user sends a query. The query gets converted into embeddings thanks to an embedding model. The embeddings are then used to find responses within the vector store that are closest to the question, and then that is passed to the large language model. So we talked about machine learning, and we talked about this. I think we've seen this. There's, of course, there are certain products out there that you can integrate our MCP server with, and the two that we have tried so far is Claude and Klein. Both of them work just fine. You can also create your own client as well. But essentially, it exposes a bunch of capabilities like training models, executing SQLs, listing tables, loading vector data from unstructured data like we did earlier. So here's an example of that, right? So as you can see, this is a set of interactions that we've had and the responses from the model. This is, of course, Claude UI, and these are the responses we got based on our questions. This is obviously in using the MCP server to get all the data that we need. Yeah, so if anybody wants to explore generative AI and wants to get started very quickly, we have a discovery workshop that we run, and based on that, we kind of figure out what has to be done. They'd have to have an OCI tenancy. Of course, they have to be using MySQL database, and and hopefully a development team if they want to develop a front end. We have a cookie cutter front end that they can use, but if they want to customize it, that is something that they can explore on their own. The scope, of course, is we are looking at generative AI use cases and use cases that exploit capabilities within HeatWave, such as NL to SQL, RAG, ML. And of course, we will provide a complete architecture, a deployment document, so on, and knowledge transfer. So this is how Talk to MySQL prototype works. Essentially, you have HeatWave and you have potentially an internal or an external model. We load the data through either MySQL or through Object Store, and you can have business users have a conversational app that can talk to MySQL HeatWave through an OCI compute instance. Yeah, I think this is pretty much obvious. So one of our biggest customers today is the Department of Goods and Services Tax Network, Government of India. This takes care of all the taxes, keeping track of all the goods and services taxes. Everything that is sold in India pretty much comes under the purview of the GST, and it kind of gives you a sense of knowing how large a country India is. You can gain an understanding of the scalability that MySQL AI brings to bear.